When Albert Einstein devised his groundbreaking theory of relativity, it was built on the foundation that the speed of light remains the same. But researchers suggest this fundamental concept, which underpins much of modern physics, may not be as constant as Einstein thought. Now the group which proposed the controversial hypothesis claim it is ready to be tested. At the heart of Einstein's theory of relativity is the idea that light travels through the vacuum of space at a constant speed. It has been used to work out the age of the universe and gives cosmologists an idea what happened just after the Big Bang. However, in the late 1990s, physicist Joe Magujo from Imperial College London suggested that the speed of light may have varied in the early universe. In the seconds after the Big Bang, physicists believe that the universe expanded rapidly from a single point in a process called inflation. But if light traveled at a constant speed, then not enough time has passed since the Big Bang for photons to reach the edges of the visible universe, resulting in what scientists call the horizon problem. To solve this, researchers suggest that the speed of light fluctuated during this early period, traveling faster in some regions than others. If true, it would have left its mark on the cosmic microwave background radiation, the radiation left over from the Big Bang, in a spectral index. Now, Professor Magujo and Dr. Nyayesh Afshorty from the Perimeter Institute in Canada have used a model to put a number to that index. The theory, which we first proposed in the late 1990s, has now reached a maturity point. It has produced a testable prediction, said Professor Magujo. If observations in the near future do find this number to be accurate, it could lead to a modification of Einstein's theory of gravity. The idea that the speed of light could be variable was radical when first proposed, but with a numerical prediction, it becomes something physicists can actually test. If true, it would mean that the laws of nature were not always the same as they are today. From their models, they have come up with a figure of 0.96478, which can be tested against readings of the cosmic microwave background taken from space telescopes. The latest measurements from the Planck telescope put the value at 0.9655 within just a few decimal places. If the figures can tally up, it could mean that the speed of light in the early universe was far greater in order to reach the edges of the visible universe before it slowed down to its current value.